let's dive right into module 4. Sorry for the mistitle right there, but this is module 4. So we're going to import our libraries as usual, and then we're going to import a data set. Now this data set's actually pretty interesting. It's very commonly used when learning machine learning. It has data on different measurements of tumors in people, and so it also has, in addition to the various measures, it has whether that tumor is malignant or cancerous. And so we can download that data set the same way we did before from GitHub by clicking on the raw button on one of the GitHub files. And so we can just save that URL and then read it as a CSV as we have been doing. And you'll notice that this is what our data set looks like. Now, we can just drop that first data column by using the drop function and then access equal to 1 and override by doing that. So now we can get rid of that. Interesting. Did not look like it worked. Now it did. So now that data column has been dropped. And so what I first want to show is the various columns. So these are all just different measurements for the tumor. And so what we want to do in this kind of exercise is to try to predict whether it's a tumor or not using machine learning or neural networks. And I'm only going to introduce a few algorithms in this, just 2, but it will give you kind of a general idea of like how to manipulate the data in order to get it ready for that analysis. But before we do that, before we get into any of that, we first want to plot the data to show some correlations. So before we actually plot the data, I want to show just some simple correlations. So I just kind of selected these columns randomly. You can select whatever you want. And I put it in this list. Remember, lists, you can see whether an object is a list by using the type function. And indeed, that is a list. And then we want to put that list inside our lock function. Because these are columns, we of course want to have that on the right side of the lock function rather than the left side, which is 4 rows. And so I'm just showing you now that that only selects a few columns. And so I want to basically do that same thing I did there, but rather than use the head function, I'm going to use the correlation function. So it's just CORR, and that will show you kind of a correlation table. Now, a lot of times in analysis, you want to do this just in order to kind of see how different columns or I guess features or regressors interact with each other when we're putting it into a model. This tends to be important. I'm not going to go on too long about that, but it's kind of important, so I wanted to show you. And then we can scatter plot. We can create a scatter plot. And I think I showed you how to do that in the last video, but this is slightly different. I'm going to be typing in PLT scatter, and I'm going to tell this function to select the area mean column as the x-axis and the y-axis the concavity mean. So here, and then I'm going to tell this function that it is selecting from the df data frame, so that data frame that we have. If I didn't have this correct, it wouldn't work because it wouldn't be able to access the data frame. And if any one of these was not spelled correctly, it wouldn't work. So we got to make sure that everything is lining up perfect. And now we have a scatter plot. So it looks like there's kind of a tight correlation between those two categories. So that's just kind of introducing the correlation and how to do scatter plots. Now I want to do a little bit review of how to change column data. Or actually, I guess row data is what this should say. It should be row data. So for the diagnosis, so this is whether the cancer tumor, sorry, whether the tumor is cancerous or malignant. So I'll show you that. So I'm just typing in the diagnosis column, right? That's the diagnosis column and using the unique function. Now you might notice that I use the same functions over and over, and that's just because oftentimes we're only working with a few functions. So these are really good to memorize, like the unique function is and the column function as well. So I'm creating this dictionary. Now remember, this is just a dictionary type, and we have the values, which is the left side, and that's the values are the right side, and the keys are the left side. So you can see that's there. I'm in the B. And so what this allows us to do here, what this is going to allow us to do is for me to change all of the M's to 0 and all of the B's to 1. So if I type in the name of that diagnosis column, and then I type in map, and then I put in that dictionary inside, what that will give me is a long list of the diagnosis column, but it will change all of the M's to 0 and all of the B's to 1. So you can see that these M's are now 0s. And if we show the last row, you can see that there's that 1 there. It's now been changed to B. So what should we do with this? Well, there's multiple ways you could do this. You can overwrite the data set by just typing in it like that, but I don't want to do that. I want to create a new column. So how do I create a new column? Well, I type in the name of the data set, I type in brackets, and then I type in a new column. So it's a bit obnoxious that I'm doing this, but I just wanted to show you that this is can be titled anything you want it to be. So I run it, and now I look in our data set, and a lot of people might be like, okay, I don't see where that is, but you'll have to go all the way over to the right in order to see that new column name is there. The easier way is just to type in the columns function, and then we can see that new column is now there. Okay, so we were able to make that new column by using the map function that's just tacked on to any column that we're interested in changing. Okay, so now that column has been created, let's see the unique value counts. So I guess I can just value counts, values. We are going to type in the name of that new column, and then we're going to use the value counts function. The value counts function just shows you all the unique values. So if I just typed in diagnosis here, it would give me the exact same data, but instead of 1s and 0s, it's B and M. Notice that 357 and 212 is exactly the same because that data is derived from the same source, right? And what I want to do is save that data. I want to set it equal to a new object called values. Now I can print that off, and then I'm going to just type in the name of that, and then dot plot kind equals to bar, and it should give us the bar chart. So it'll show here that, in most cases, the tumor is actually, well, what did I say? Is actually not malignant. Cancerous. I think that's what the B stands for, so bear with me. But the important point is that we're trying to make a prediction, and it shouldn't actually matter, at least for the purpose of this exercise, what we're measuring. So now I just want to show you a couple of more graphs that you can do. If you want to show a histogram of one column, you can select one column name. So this is the name of the column. And you can tack on this hist function, and that will give you a histogram. You can also do that with like a number of columns at one time, so multiple histograms. And if you run that, you'll see that I have a bunch. Smaller. But I'll print off 3. I'll print off 4. All right, so all I'm doing is creating this columns list, putting in that list into the lock function, and then putting the histogram. This little colon you don't need, but it just kind of gets rid of all this junk that you don't want to see. So that's why I put it there. And so now that covers a number of graphs and kind of reviews how to change data like we did in, I think, the first module. All right, so let's move on to the interesting stuff. Let's try to predict. Actually, I think this is a breast cancer set. So that's what we're actually trying to predict. I want to rename that goofy column. So rather than new column, I want it to just say outcome. I'm just going to break this up into parts here. We're going to use the rename function. And let's see, we have to go all the way over. Okay, it looks like it worked. We can split this up though. Now calls, that in there, and here. We can do it like that as well. And then we can overwrite that, setting it equal to the name of our data frame, and we can confirm whether it worked by looking at the last 4 column names, by typing in the columns function and then slicing last 4. So it looks like it's now outcome. So the next step is to create X and Y data. So X and Y data, there's other names for it depending on what kind of field you're in. So a lot of people call the Y the dependent variable. If you've taken statistics, you might notice that the X's are going to be the independent variables. In machine learning language, it's the Y variable is called the target, and the X is called the feature. In econometrics, X's are called regressors. Okay, so we just want to create that X and Y data, split it up. So we can use the lock function to select only the outcome. So that is our variable that's not going to change. And what I want to do is use a couple of the columns to try to predict that outcome. Okay. So that's why we are selecting multiple. I mean, we could select absolutely every single one. I'm just using 2 as an example. And so this would be, for example, if you're familiar with statistics, beta 1 and beta 2. But all you need to know is that this data is going to be used to try to make a prediction on whether a person has a cancerous tumor. So now that that data has been split up, we need to do one more final step. And so this what I'm introducing you to here is really kind of the basis of machine learning, if you've heard that term before. But not only do we have to split up the X and the Y data, we need to kind of split up a training set and a test set. So what we do is we train the algorithm on obviously the training data set, and then we use that algorithm to make predictions in the testing set. And so you can just visualize that part of the data is split off. So this is the whole entire data. Part of the data is split off for training purposes. Part of it is used to test it. And then this is kind of a more complicated version that I'm not going to kind of talk about here, but there's other ways to do it as well. There's sometimes you can use training, validation, and testing. It makes the algorithm a little bit more robust, but we're just going to do this. So in general, we split the data with a library, but I just want to show you that, like, how to do it by hand. So we're going to look at our data set length. So the length of our data set, we can always use the length, the len function, and that will give us how many rows our data set is. So the length of X and Y should be the exact same because they are, at the end of the day, from the exact same data set. And so after we have that, we can save it. We can save that number as an object. So I'm just calling it data length. And so in general, there's about 20 to 30% of the data that is used for testing and 70% to 80% using for training. So I'm just taking that data length and I am multiplying it by 0.3, so 30%. And that gives me a number, but that number is not round. So that's why I'm going to use the round function. So roughly 171 of the data points are will be used in the test, and the remaining will be used in the training. So I'm going to create this test data by using the iLock function. So this is very similar to the lock function. The intuition is exactly the same. But in this case, you can use numbers rather than the titles, okay? So in this case, I'm telling it to select the 0 to the 171st or 170th, I guess, row. So you can see that it's this is the tail function, so it shows the last two rows, and you'll see that it goes up to 170. Remember, the numbering in Python is not inclusive. So if I typed in 170, it would give me give me until 169, like that. But I want to do that, and actually, you can, to make this a lot easier, what you can say is test length equals to there, and then problems, test length equal to 171, and then that way I can just put that like that, and then that will give me the same thing. So now I'm going to use that function to create new data sets. So this will be the test, and this will be the X test and the Y test. So let's just actually do this. This is actually better coding practice. And now I have the X test. Oops. And so that's the first 170 rows in the Y test. Now, when you're actually doing a train test split, like not by hand, this is just by hand. A lot of times it will randomly select the rows because it makes it, I think, more robust statistically, but I'm just kind of showing this as an example on how to use the iLock function I wanted to show you. So this is just printing off the first two rows of the Y test and the X test, and then this gives a space in between those prints. So the N and this just creates a space. So this is the Y, and then this is the X. So that's how to create the test data, the train data. I guess I really should be doing this. So that's the test data, the train data, same concept, but you'll notice something different. I selected until the 170th data point here, but from now on, I want to select from it, so we're not overlapping. So you'll see it starts at 171 and then ends at the very end of the data set. So that's what we're going to do there. And then I can just manually type this equals to y dot iLock test. And so now I have those two saved. And we can do the same thing here. Print off the y, print off the x. Now, just to, I guess, show you one more example with the iLock function, let's go back to that original data set, just because you're probably confused a little bit about the iLock function. So the original data set, say I want to select the first two rows and the first two columns. This is how I would do it. Let's say I wanted to select the Senka through the 5th row and the 3rd through the 9th column. So I think this should give you a better idea of what that iloc function does. But now let's circle back to our data set. So let's confirm that that train and test data set combined is the same length as the total data set. So the X test is 171. The X train is 398. So the Y should be exactly the same. Yes, it is. And it should be equal to the length of X. Because X, basically, X is just these data sets combined, right? So we can actually just write that in this here, statement here, and it will equal to true if they are equal. So they are. So that worked. So we know. All right, so now let's get on to our model. So this is just actually not a fancy model at all. This is just logistic regression. So some of you are familiar with regression. Fewer of you are probably familiar with logistic regression, but it's just a type of regression for categorical data. This categorical data is the diagnosis. A lot of times regression can also be with continuous variables like housing prices or grades, score on a test. But in this case, it's a 0 or a 1. Yes or a no, more or less. And so in that case, we use logistic regression other than regular. So I'm just importing that from this kind of, I guess, machine learning library called sklearn. And so I'm importing this logistic regression function. And then I'm creating this model using that logistic regression function. I type in fit. And then inside that fit function, I put our train data. So our trained X data will go on the left and our Y data will go on the right. And I'm just saving that as a model. If I didn't save it, it would just give me some kind of weird output there. So once I have that model saved, basically it's been trained, you can think of. And what I want to do next is I want to use that model. So you see that model is titled model. I want to use that model and I want to use the predict function. And inside that predict function, I want to put the test data. So basically what this is doing is I'm feeding it in that test data, and then it's using that test data based on the training here to make a prediction about whether it's a 1 or a 0. So whether the cancer is malignant or not. So these are my predictions, okay? And I'm just saving that as model predict. So just to clarify, if I save this model as model log, then I would have to change this to model log, but it would be the same exact thing. So notice that this training data will go into the fit function, and the test data will always go in the predict function. And so now I have my predictions, and I'm going to use yet another function from the sklearn library, and it's called accuracy score. And so inside that accuracy score, I'm going to put the original test data that I have and that model prediction that we have here. And this will give me the accuracy of the model. So the model actually did pretty good, did decent. It predicted correctly 78% of the time, whether it was cancerous or not. Okay, so that's the basic kind of model that you can have. But it's kind of cool that this sklearn library also has kind of more advanced algorithms like neural networks. I get a neural network, I guess, is technically what a lot of people in the media would refer to as AI. I don't know if that's exactly the correct reference, but this is what I think the simplified form of what's been getting a lot of hype in recent years. So I am just importing this model as I kind of imported it up there. And so again, like here, I'm just taking that model exactly there, like this. It's titled the same, as you can see. It's titled the same. And inside of that, I'm going to tack on that fit function, and inside again, training data. So training in the X, training, and then Y on the right side. And I'm going to save that. So let's save that as model NN for neural network. So I run that, and so now the model has been trained. And then I'm going to use that model NN. So model NN predict, and inside I'm going to put that test data. So again, think of it as using that test data there to make a prediction of the Y data. Okay. And so this data has been, this model, this prediction is based on this training here. Okay. And so it spits out some predictions. I can save those predictions. Careful. Need to make sure that the naming is correct. And then I'm going to use that accuracy score. Let's just model predict NN and model predict NN. And it looks like the neural network AI was not so good after all. It actually did worse than our logistic regression. So I mean, I think this is actually a great example of how we have all these tools now available to us through Python, and sometimes they can be a fancy tool, but if we're not using it the right way, it might not really work. I mean, I didn't show you, but within this neural network, you can define a lot of different parameters to I guess make the neural model deeper. You can create different optimization settings. There's different things that you can do. So out of the box, it doesn't work that well. But I really also wanted to kind of show you this example to tie in the power of Python in terms of being able to manipulate the data, graph the data, and then make models with the data that are, in often cases, this same framework is used to control a lot in our lives. From the search engines that we use to, uh, different recommendations engines on applications and different stuff like that. So hopefully this piqued your interest to learn a little bit more on machine learning and data manipulation. And I look forward to discussing it more in the live sessions on Friday. Thank you.